So now we go towards the 4 different colligative properties. Uh, so we need to know about 4 different colligative properties. I'll not go in detail, I'll just name them. So the first colligative property that we need to know is relative relative lowering of vapor pressure. Vapor pressure, relative lowering of vapor pressure. Then we have osmotic pressure, relative lowering of vapor pressure, then osmotic pressure. Then we have the third one to be elevation of boiling point, elevation of boiling point, and the fourth one to be depression of freezing point, the depression of freezing point. So it's very simple. So it's the 4 colligative properties that you need to know for your standard is relative lowering of vapor pressure. So how? By changing the amount of solute, right? By changing the amount of solute present in a solution or a solvent, the vapor pressure is lowered. So कति मैले solute particle कति हाल्दाखेरि vapor pressure decrease हुन्छ कि, right? If I remove the solute particle, will it cause a lowering of vapor pressure? So that we need to study in this. So here we already know what is colligative property, right? It will not depend on the chemical property of the solute. So we don't need to talk about the chemical properties of the solute. We just talk about the physical aspect, the presence of the solute and absence of the solute. So will the absence or presence of more solute cause the lowering of vapor pressure? That is the thing we need to study. Similarly for all the things, boiling point पनि त्यही हो. So solute particles present हुँदा या absent हुँदा, what will happen to the boiling point and freezing point and osmotic pressure? So all these things are they have the same property, they have the same way to proceed, right? So we'll talk about solute particles being present in a solution and how the presence or absence of these solute particles will affect them. Okay, will affect the colligative properties, will affect these properties, right? Presence or absence of solute will affect these 4 properties. So we'll study that. So before that, let me talk about volatile. I have done this before. So volatile substance and non-volatile substance. So what is a volatile substance? So volatile substance is basically a substance that is ready to change, right? Ready to undergo a chemical change, ready to undergo a state change, right? So volatile substances, not necessarily always a state change, right? But volatile substances are always ready to carry out a change. They are always to take part in a change reaction, right? They take part in a reaction and they change themselves. Like they don't need to be part of a chemical reaction. Like some solids can be volatile by just effervescing in the atmosphere, right? Some solids, when you place like in open air, they just mix up with the atmospheric vapors and just vanish in air, right? The solid particle is no more. So all those things can be termed inside volatile substances. So volatile substances are substances that are ready to change. They are always ready to change. They can always have the tendency to change from one state to another or one process to another. Right? This state change is considered one of the most like volatile. सबैले त्यसरी बुझ्छ हो क्या volatile substance भनेको, a substance that is easily changing its state. So that is the way most of the people understand volatile substance. But the better way to understand volatile substance is not only physical or like state change. Like volatile substances undergo changes that may be visible, not visible, all those things, but they undergo some changes. They undergo some chemical changes. Those chemical changes may be glorified by like some accompanying physical changes, but that is just a subordinate. क्या हुन सक्छ हुन सक्दैन. It is not necessary that there is always a state change. Always a state change हुने केही necessity छैन. But volatile substances, you should know that volatile substances are readily changing. They always change, right? So this is the thing you need to do. So similar to like if you just go to opposite, it will be the non-volatile substances which are not changing readily. They don't like to be changed, right? So these are non-volatile substances. It's very simple. And 2 more terms, I think: dissociation and ionization. So what is dissociation? So Dissociation भनेको चाहिँ, so when something dissociates, so these topics are all required for studying the colligative properties later. So first, dissociation. So if I say sodium chloride is called this is table salt, right? This is table salt. So dissociation of sodium chloride means your like यसमा चाहिँ यो सोडियम क्लोराइड सल्ट पार्टिकलमा युआर एप्लाइङ सम एक्सटर्नल फोर्सेस, राइट? फोर्स भन्दाखेरि इट्स नट अलवेज द फोर्स द्याट यु अन्डरस्ट्यान्ड वेन आई से फोर्स, सो ठेल्नु ए पुल समथिङ, सो द्याट्स नट अलवेज द फोर्स. So when I'm talking about force, I can be talking about the energy aspect of force, right? So when I talk about force, I may be talking about the energy aspect of force. So what energy that the force brings out, right? So if I apply some energy, let's say external energy, let's not confuse ourselves by force. Let's say if I apply some external energy to NaCl, let's say I heat it, right? So heating, or further, let's say melting. So I melt sodium chloride. So melting of sodium chloride will cause the bond between sodium chloride. The bond between sodium chloride is ionic, right? So ionic bond बनेको. So Na plus will come close to chloride ions because they are positive and negative. So unlike charges will attract. So these two are held together by strong forces of electrostatics. So they are held together by strong forces of electrostatics. And when I heat or melt them, this force of attraction between the positive and the negative is somewhat lost, right? And because of that, sodium ion is free and chloride ion is free. So this is known as dissociation of something. So if a chemical compound dissociates into its constituent parts, then that is known as dissociation. When it splits up into its constituent parts, that process is known as dissociation. Alright, okay, and this process can also be termed as ionization, right? Ionization भनेको त्यही कुरा. So a compound which, like, initially you can't say that this has ions, right? You can't say that sodium chloride as a crystal will have sodium ions and chloride ions. No, you can't say that. The ions are held together, and because of that force, we consider them to be neutral, right? So only when they split up, we can say that it is sodium ion and chloride ion. So this process is known as ionization or dissociation. So something is dissociating, right? And one of the factors, one of the processes, like, to carry out this dissociation is by heating or melting something, right? Another simple process to do this is by adding water to something. So when you add salt to water, what happens? Simply the salt, which is in the solid state initially, dissolves with water, which is in the liquid state, and completely dissolves, right? You don't see solid salt there unless you put like excess amount of salt. If you put adequate amount of salt, let's say a glass full of water, and you just put like half spoonful of salt in it, so the salt will not stay in the bottom, right? The salt has the tendency to dissolve itself in water. And what is actually happening is, what is breaking the sodium chloride, the bond in between sodium and chloride, has been broken by water. So water is a polar compound. So polar compounds are notorious for this. They are known for doing this. They are known for breaking the bonds between ionic compounds, right? So there's ionic compound like sodium chloride or potassium chloride, something like that. Polar compounds like water have a tendency to break the bond between them, right? So adding salt to water will break the bond between sodium and chloride, and sodium becomes a free ion and chloride becomes a free ion. And this is also a development of a fact that salt water is very conducting. So we know the fact, right? I have been telling you about this fact. You know about this fact. I don't need to tell you about this fact, right? Salt water is conducting. So why is it conducting now? Now this is one of the best explanations for this. So when you put like salt in pure water, the water will act as a force to break the bond between sodium and chloride ions, and sodium ions and the chloride ions are free. They move around in the salt solution freely. So when something is moving freely, when ions are there to move freely, or when electrons are there to move freely, then those are the reason why electricity conduction happens, right? So why does conduction happens in metals in first place? So metals ma conduction huncha because they have a lot of free electron density, right? They have a lot of free electrons inside there. So that causes the electricity or current to flow through metals, right? Similarly, for like ionic solutions like this, basically ionic solids are placed inside polar compounds, so that will cause the breaking of the ionic solids, into its ions, constituent ions. So that those ions are responsible for conduction, right, in the liquid solution, or we like colloquially term it to be electrolyte, right? Electrolyte. So electrolytes are things that allow the flow of current through them, right? So electrolytes are liquids or liquid solutions that allow the electricity or current to flow through them. So that is electrolyte. So this is dissociation or ionization. So dissociation is basically breaking up of compounds into its constituent particles, constituent parts, right? Dissociation. And ionization is also the same. So a compound is ionizing, is dissociating into its constituent ions. So that is also ionization, also dissociation. So almost both the terms are almost the same. And this that I think we dissociation, ionization, and okay, the electrolyte one. So let's come to like a subordinate term with electrolyte. It is strong electrolyte and weak electrolyte. Strong electrolyte and a weak electrolyte. Right. So strong electrolytes are basically compounds that completely dissolve into ions in its aqueous solution. So something like sodium chloride. Sodium chloride, when placed in water, will completely dissolve into sodium ion and chloride ions, right? Aqueous solution. Right? So you'll not find any molecules of sodium like moving around the thing. You don't find molecules of chlorine moving around, right? It's not possible. It's like completely, the sodium is completely free, sodium ion. Chloride ion is also completely free, it's moving, right? So a strong electrolyte is an electrolyte that completely dissociates into its constituent ions. So completely there is no molecular compounds or molecules present in the product, right? So that is a strong electrolyte. Now weak electrolytes are basically from organic compounds, like let's say an organic acid, CH3COOH, or let's say CH3COOH, correct. So when you dissolve this in water, so you get a reversible reaction of H3O negative, H3O plus CH3COO negative. Now this is the complete dissociation of a weak electrolyte. So weak electrolyte will have ions in its aqueous state. So you have to note down the fact that weak electrolytes, like you can't come to a conclusion that weak electrolyte बनेको यिनीहरूको aqueous state में ions हुँदैन. No, they have ions in their aqueous state, but they are not as effective as strong electrolytes. They are not completely dissociating into ions. So they are like partially dissociating into ions, and some are staying as molecules. So molecules are useless in conduction, right? So molecules do not conduct. So molecules are basically neutral substances. And we know that neutral substances are very bad conductors of heat and electricity, right? Something has to be in abundance in a particular material to make it conducting. Like for metals have abundance of electrons, right? They have excess of electrons. So this causes the metals to be good conductors of electricity, right? So the presence of electrons in metals in abundance causes the free movement of electrons, right? And this causes the conduction of electricity. So weak electrolytes are basically electrolytes which do not completely dissociate into ions. So they do not have complete ionic dissociation. Rather, they have some ionic dissociation, but with it, they have molecular dissociation as well. So they have molecules in their product, which molecules are totally useless in conductivity because they are very neutral, right? So weak electrolytes are weak because they do not completely dissociate into ions in their aqueous state, like the strong electrolytes. So strong electrolytes like sodium chloride, potassium chloride completely dissociate into ions in their aqueous solution. So that makes them like strong electrolyte, right? So these are the things you need to know. What is ionization? Ionization and dissociation, they are almost the same. And so breaking up of a compound into its constituent parts is known as ionization or dissociation. Then we have electrolytes, right? So electrolytes are basically solutions, liquid solutions, or solutions in general that conduct electricity, that allow the electricity flow through them, that allow the flow of electricity through them, right? And there are two types of electrolytes: strong electrolytes and weak electrolytes. So strong electrolytes are electrolytes that completely dissociate into ions in their aqueous state, while weak electrolytes are electrolytes that partially dissociate into ions and partially into molecules, right? So because of the presence of molecules, these things are like like very bad at conducting, not as effective as strong electrolytes. Okay, so this is the introduction to colligative properties. So tomorrow we'll go in detail with all the 4 colligative properties. So I didn't give any like insight on the 4 colligative properties because like I didn't want to start something and not end it because it's very long. It'll take 1 complete hour for this colligative properties. So tomorrow colligative properties thalchu and I'll maybe complete it by tomorrow itself. So yeah, this is it for today.